Hello everyone, I'm Lo. I'm a chemistry teacher and welcome to my course. In this series, I'll be covering topics from both the A-level and the IB chemistry programs. We'll be focusing on three important parts from the first part of the course. These parts are essential for building a strong foundation in chemistry. Each part includes chapters that break down the topic step by step. Throughout this course, I explain the key concepts in a clear and simple way. And I also include examples and exercises to help you understand and apply what you learned. In each lesson, I start from the basics to make sure everyone understands the core ideas, whether you're just beginning or reviewing what you've already studied. This helps build confidence before moving on to the more advanced concepts. And let's begin with the first chapter, Structure of the Atom. But before we jump into learning about atoms, I have a question for you. What comes to your mind when you hear the word chemistry? Maybe you picture mind, test tubes, bubbling liquids, or people in labs coats mixing strange substances. But chemistry is much more than that. It's the science that studies matter and how it changes. Chemistry explains how things are made, how they react, and how new substances form. From cooking food to cleaning stains, from medicine to makeup, chemistry is everywhere. For example, when you boil water, it changes from a liquid to a gas. When you freeze water, it becomes a solid. These changes from solid to liquid to gas are all parts of chemistry. So, what is chemistry again? Chemistry is the study of matter and the changes it goes through. That means chemistry helps us understand what things are made of, how they interact, and how they transform. Now that we know what chemistry is, the next question is, what is matter? Matter is anything that has mass and takes up space. That means if you can touch it, see it, or feel it, it's probably matter. Even things like air and water vapor, things you can't always see are still matter. Matter can exist in different states: solids like ice or a rock, liquids like water or milk, gases like oxygen, steam, or the air inside a balloon. However, not everything is considered matter. Things don't have mass and take up space, so even though you can see, hear, or feel them, they're not made of matter. For example, light, sound, or heat. These are not forms of matter. Matter can be described at two levels: macroscopic, and this refers to what we can see, touch, or observe directly. For example, water, ice, metal, or smoke. Microscopic. This refers to what happens at the level that we can't see with our eyes. And here we're talking about atoms, molecules, and ions. And that's brings us to the most important starting point in chemistry, the atom. Because that's where everything in chemistry begins. So, what is an atom? Let's make a quick review about the basics of an atom. We've known for a long time that everything around us is made of tiny building blocks called atoms. Atoms are incredibly small, so small that we can't even see them with the most microscopes. But what's really amazing is the atoms themselves are made of even smaller parts. Even though atoms look solid, more than 90% of an atom is actually empty space. At the center of the atom is the nucleus. And around the nucleus, we have electrons that move in invisible paths called electron shells. Every material you see, metal, water, air, is made up of different types of atoms. In fact, scientists have discovered 118 types of atoms, called elements. Out of those, 92 occur naturally and the rest are made in labs. Now let's take a closer look at this atom. As I mentioned earlier, we can split an atom into two main parts: the nucleus, which is the center of the atom, the electron shells, which are the spaces around the nucleus where electrons move. And let's start with the electron shells. You can think of them like invisible rings or energy levels that surround the nucleus. This is where electrons move. I'm talking about the particles with the negative charge. Electrons are incredibly small, about 1,800 times lighter than protons or neutrons. Even though they're tiny, they play a big role in chemical reactions and how atoms bond with each other. Now let's move on to the nucleus. It sits right in the middle of the atom and is made up of two types of particles: protons, which carry a positive charge; neutrons, which have no charge. They're neutral. Protons and neutrons are about the same size and mass, and they pack tightly together in the nucleus. The nucleus is super strong and stable, and very hard to break apart. Move on to one of the most important tools in chemistry, the periodic table. The periodic table is a way to organize all the known elements based on their properties and atomic structure. Each element in the table represents the different types of atom with the unique number of protons in its nucleus. Every chemical element has a symbol. It's written with a capital letter, sometimes followed by a lowercase letter. Each atom has certain values that define what it is. Let's break them down. We represent atoms using these formats: X, Z, A, and Q, where X is the symbol of the element. It represents any elements on the periodic table. Z is the atomic number, or the number of protons. The atomic number, or number of protons. Elements are arranged by their atomic number, from the left to right, and by their similar chemical properties in column called groups. Alright, back to our atom, and let's take a closer look. First, let's count how many protons we can see in the nucleus. Remember, protons are the blue particles with the positive charge. So here we can see 1, 2, and 3. We can see 3 protons. That means the atomic number Z is 3. And this tells us what element it is. If we check the periodic table, Z equals 3 corresponds to lithium. Another atom, this time we have 1, 2, 3, 4, and 5. We have 5 protons in the nucleus. That means Z equals 5. So we find the element number in the periodic table. It's boron. One more example. The nucleus has 1, 2, 3, 4, 5, and 6. 6 protons. That means the atomic number Z is 6. If we check the periodic table, it's carbon. So Z is the atomic number, and it tells us how many protons are in the nucleus, and this number defines the element. For example, if Z equals 1 proton, the element is hydrogen. If Z equals 2, the atom has 2 protons, the element is helium. If Z equals 8, that means 8 protons, the element is oxygen. Now, let's talk about A, which is called the mass number. A stands for the total number of protons and neutrons in the nucleus of an atom. Why is it called mass number? Well, because protons and neutrons are particles that make up most of an atom's mass. Electrons are so light, they barely add any weight at all. So when you want to know how heavy an atom is, you add up its protons and neutrons. A equals Z plus N, where Z is the number of protons, N is the number of neutrons. This number is especially important when you talk about isotopes. Wait, isotopes? What does that even mean? Don't worry, we get to that. But before we dive into isotopes, let's take a couple examples to understand how to define the mass number A. Back to our example. Here we have 5 protons, element is boron. A equals 5 protons plus 1, 2, 3, 4, and 5. A equals 5 plus 5 equals 10. Another example, Z equals 6, A equals 6 plus 1, 2, 3, 4, 5, and 6. A equals 6 plus 6 equals 12. You might also see a small q, which tells us the net charge, whether the atom is neutral, positive, or negative. But hold on, before we get into charge, let's take a moment to understand what isotopes are, because they're directly related to the mass number. Let's take a look at these three atoms. To identify an atom, the first thing we need to know is Z, the number of protons. Here we have 6 protons, which means Z equals 6, and that gives us a carbon atom. Move on to the neutrons. 6 neutrons, A equals 12. The second atom, we have 6 protons, which means Z equals 6. It's a carbon 2, but let's count how many neutrons here. 1, 2, 3, 4, 5, 6, and 7. We have 7 neutrons. 6 protons and 7 neutrons, that means the mass number A is 13. The third one, we have 6 protons, definitely carbon, and 1, 2, 3, 4, 5, 6, 7, 8 neutrons. Here A equals 14. So what's the difference? They're all carbon because they all have the same number of protons, but their mass numbers are different. The first one is carbon 12, the second one is carbon 13, and the third one is carbon 14. And this leads us to the definition of isotopes. Isotopes are atoms of the same element that have the same number of protons, but a different number of neutrons. That's why we get carbon 12, carbon 13, and carbon 14. They're all isotopes of carbon. Now, let's talk about the net charge, also written as a Q. The net charge is the overall electric charge of an atom or ion. And here we see a new word, ion. Don't worry if it's new to you. I'll explain exactly what an ion is in just a moment. Okay, now back to the net charge. It all depends on the balance between the two key particles. Protons, they carry a positive charge. Electrons, they carry a negative charge. If the number of protons equals electrons, the charges cancel out and the atom is neutral. Just like what we see in the lithium atom. 3 protons in its nucleus, and it also has 3 electrons moving around in its electron shells. So, what do we get? 3 positive charges from protons and 3 negative charges from electrons. Plus, minus, plus, minus, plus, minus. That means the positive and the negative charges are equal. They cancel each other out. So the lithium atom is neutral. It has no overall charge. But what if the lithium loses 1 electron? So we have plus, minus, plus, minus, plus. No third electron. That means there are 3 protons and only 2 electrons. So the atom is no longer balanced. It has 1 extra positive charge. And that's when the atom becomes an ion. And the lithium becomes Li1+. Another example, we have 8 protons, which means Z equals 8. It's an oxygen atom. A equals 8 plus 8 equals 16. And we can think of the charges like this: plus, minus, 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 plus, minus. A neutral oxygen atom has 8 protons and 8 electrons, so it's balanced. All the positives and the negatives cancel out. So oxygen is neutral. But what happens if oxygen gains 2 extra electrons? Now it has 8 protons and 10 electrons. That's 2 more negative charges than positive ones. This gives the oxygen atom a net charge of -2. And now we have O2-. It's no longer an atom. It becomes an ion. So, what's an ion? An ion is simply an atom that's gained or lost electrons. When this happens, the atom becomes charged, and that charge can be positive or negative depending on what it lost or gained. Let's look at 2 main types of ions. If an atom loses electrons, it becomes positively charged, and we call this a cation. Cation. For example, lithium normally has 3 protons and 3 electrons, so it's neutral. But if it loses 1 electron, now it has more protons than electrons, and it becomes lithium 1+. On the other hand, if an atom gains electrons, it becomes negatively charged. That's called an anion. For instance, oxygen has 8 protons and 8 electrons, but if it gains 2 extra electrons, it becomes oxygen 2-, a negative ion. So, the net charge depends on the balance between protons and electrons. Here's a formula that helps us to calculate the charge. The net charge of the atom, Qa, is equal to the number of protons times E plus the number of electrons times negative E, which simplifies to Z minus N times E, where Z is the number of protons, N is the number of electrons, and E is the elementary charge. It's around 1.6 times 10 to the power of -19 coulombs. But to keep the video short, I explain what E, the elementary charge, really means in separate video. For now, just remember, ions form when atoms gain or lose electrons, and that's what gives them positive or negative charge. Let's wrap everything up with a quick summary. First, if atoms have different number of protons, they are different elements. For example, boron has 5 protons, carbon has 6, nitrogen has 7, and so on. That's how we get all the different elements on the periodic table. It all depends on the number of protons in the nucleus. Second, if atom has the same number of protons but different numbers of neutrons, they're called isotopes. Take oxygen for example. Every oxygen atom has 8 protons, but some have 8 neutrons, some have 9, some have 10. These are different versions of the same element called isotopes. And finally, if the atom has the same number of protons but different numbers of electrons, we call them ions. For example, sodium Na normally has 11 protons and 11 electrons, that's neutral, but if it loses 1 electron, becomes Na1+. To sum up, different protons, different elements. Different neutrons mean different isotopes. Different electrons mean different ions.